All right, we'll give it a few moments. So I was hoping that we would have some people that are here today, but attendance is totally required. Welcome to Psych 503. My name is Jason Mack. You can refer to me as Jason Mack, Jason, Dr. Mack, Professor. Anything other than hey you is absolutely fine. I'd really like to know if this is a good time to meet. Now, you don't have to meet. It's absolutely not a thing. But I would encourage you all to meet because you'll get a lot more out of class that way. Talk about the classroom a little bit in terms of just knowing where everything is. And don't worry about it if you don't have the material immediately. There is, I believe, like a 11-day or 2-week trial, so you don't have to have it immediately, everybody. I sure hope I'm not talking to myself for the next hour or two. Hope some people join us, but if not, don't worry. I will go ahead and get this posted for everybody. So just a couple of things here. Let's go ahead and do a screen share, okay? So this is a grad course. I will be here to help you along the way. Think of me probably more like your teacher rather than your coach rather than your teacher. We will absolutely get you there. Now this is designed to be a completely autonomous course. You don't have to attend. You can. Now I've taught stats for quite a while, and usually folks that attend get better grades. So if you can attend, probably better. If you can't, not the end of the world, but I strongly encourage you to watch the recordings. Hopefully you're watching, at a minimum this recording. So let's just talk about the classroom a little bit. Everything's going to be pretty much there for you, plug and play, that sort of thing. So our classroom looks like this. I'll do a screen share in just a second. So here we go. So this is our classroom, everybody, for those of us that I think maybe you're all just watching this later, which is totally okay. So you have your syllabus, contact me. Now books, you need to get the books and you need to do Cengage. Now, Cengage, I believe is about $40. You don't have to do it today if you're concerned about that. I think somebody emailed me. You just need to do it soon. You don't have to do it today. Okay. Now, Cengage is something where you walk through the modules and you earn points for that, and that's all notated in the syllabus. But you have the opportunity to really get through the material. Then I also have some in-class assignments right here. So, for example, we have these assignments, which we'll walk through. So the icebreaker stats, that one I want you to do on your own. The icebreaker, that's really about just explaining a little bit about yourself, give me a chance to get to know you a little bit better. We typically don't talk about these in class. We could if folks decide to attend. You select a meme, copy the picture to a Word document, explain why it was chosen, place your theme song, design your own custom license plate, make a list of 3 pet peeves about college classes and 3 things you hope to learn from this class. That's just for me to get to know you all a little bit better. And then we have our Dr. Java research study. We usually do that in class. I'll certainly walk through that a little bit with you guys. We have our hypothetical research questions, which I'll walk through that a little bit with you guys. And then we also have our infographic. And this is supposed to have a little bit more information in here. So I'll see why it seems not to be having that additional information in there. And that looks like that's hidden. So we'll update that and we'll actually update that to the correct information here. So the infographic, we're talking about differential and descriptive statistics. And we'll update that file because that file should actually look a little bit more like this. I'll show you that in just a moment. You guys should absolutely call me, text me, email me if you're stuck. This is statistics. I want you to be successful. My number is 786-879-0179. I think that uploaded correctly. Okay, so let's go like that. So what you're going to do is you're going to create an infographic. If we end up meeting, I might have you present it. I might just have you upload it. I want you to think about what your career is, what you're going to do after grad school. And you can use these links right here to talk about that. And this is absolutely an available assignment. You should absolutely do this week. We also have hypothetical research, which looks like that is visible. You guys should be able to see that. The Dr. Java research study and icebreaker statistics. So let's start with just a little bit of lecture here, everybody. Like I said, I hope some of you join me. Hopefully I'm not lecturing to myself, but if I am. At the end of the day, I want to be able to support you guys. So I'm going to stop the share just for a second, see if anybody's shown up, but looks like no one has. So let's talk about some stuff in terms of statistics. Just a second to open some stuff up here. All right, here we go. And I have two screens, so if you see me looking off camera, guys, that's absolutely why. All right, so let's just give you like just a rough background. So stats, don't let it freak you out. It's just we're using data, we're talking about it. Descriptive statistics tell you what's going on. Inferential is where you draw meaning. So when you're talking about those infographics this week and your job, you might want to talk about like why you want to do it, some qualitative stuff, things of that nature. So chapter 1 outline, we're going to talk about stats, what they are, what a population of sample is, some research methods, major types of that, some scales of measurement, some classification of variables, and SPSS computer software, data entry by spreadsheet. I believe you can go online and just type SPSS grad pack. Just Google that if you're trying to save money in addition to the link that I provided for the SPSS worksheet, or not worksheet rather, but software. So statistics, we're just summarizing, analyzing, interpreting observations. That's what stats is. Again, don't let it freak you out. Data, that's just literally raw score numbers that are according to rules and observations. This will allow for quantitative analysis. We have both our descriptive, that's just a summary, like what's happening with your statistics. And then we also have inferential that allows sample results to be generalized to representative populations. And don't worry about all that terminology and all that vernacular. It just means inferential, meaning descriptive, sort of describing, telling you what's going on. And again, to inferential, we want to interpret meaning. So some applications to research. You always want to think about like asking a question. You might want to think about, for example, does adding sugar to grapefruit juice increase the intake of juice? Like, do people want to drink it because of all the sugar? Because, hey, it tastes really good, for example. Now, you also might want to think about, just update this just a second. Like some better audio. I think we have better audio now. Sure looks like it. Just double check here. Stop the share for just a moment, just do a quick mic check. Yeah, so you guys can hear me, and that probably sounds better just so we have a good recording here. All right, so yeah, some questions, set up a research study. We would break participants up into two groups. One group drinks grapefruit juice, one with and one without sugar. Then you're going to measure the behavior, measure the amount consumed in grapefruit juice in milliliters, and then compare what happened with each group. That's how you do research. You come up with an idea, and then you go ahead and see if your observations make sense. So when we talk about descriptive statistics, we want to think about procedures that we use to quantify behaviors, tables, data, charts, stem and leaf plot, that sort of thing. Inferential statistics is when data are typically drawn from a portion of the overall group interest. That allows researchers to make inferences or meaning about the overall group interest. It also allows researchers to make inferences about the parameters in a population based on sample data. So the idea is we come up with a sample, which represents
the population, and the population is everybody. It's very hard to observe all of the population. That's why you use a sample that ideally is representative of the population. So population, again, entire individual or items of interest. Data are termed parameters. Sample, that's your subset of that population. Then we call that data statistics. Parameters, everybody. Sample is statistics. Obviously, just because of like the sheer volume of people on the planet, most behavioral research is done on samples. And again, descriptive statistics will summarize what's happening, the results, whereas inferential statistics will generalize to the population. Now, with research methods, there's a science and systematic study of relationships applied using the research method. There's three common methods. There's the experimental method, the quasi-experimental method, and the correlational method. So some things to think about is in terms of research methods, you have cause-effect analysis, which is your experimental design, high level of control to isolate or control the cause and effect, must satisfy requirements to be an experiment, which are manipulation, randomization, comparison, and control. So for example, let's talk about meeting some experimental criteria. A random assignment would be where we would have, which is requirement 2. You have to manipulate levels of the independent variable, which is sometimes referred to as IV for independent variable. And then, for example, let's say the effect of bold font on memory and recall. We have to have at least 2 groups observed. You have a dependent variable, what is measured or proposed effect. You have the operational definition, how will the dependent variable be measured. The experimental group exposed to the independent variable, the boldly key terms in the short passage, and then the control group, they don't have bolded key terms in the short passage. Regular font key terms in the short passage. So again, control group, no bold, experimental group, bold. The research question, does the independent variable type of font cause a difference in the dependent variable or the recall? So to summarize, you have your population and then you have your sample. We decided to do a bolded condition, manipulating one of those variables. We called the independent variable randomly assigned participants to each level of the manipulated variable and randomly assigned participants to 2 levels of bolding. The bolded condition, students read a short passage with 10 key terms in bold font. The non-bolded condition, students read the same short passage with the 10 key terms in regular font. Then we're going to compare what our results are. So we record the number of key terms correctly recalled from the bolded condition. That's the independent variable that we're manipulating. And then we record the number of key items correctly recalled from the passage. In the non-bolded condition, we measure a second variable called the dependent variable. The same variable is measured in each condition, and the difference between the groups is compared. For example, like I mentioned, we record the number of words in each condition, bold or unbolded. So the quasi-experiment, and we're going to do a worksheet on this, which I'll either assign and or walk you through. The quasi-experiment includes a non-manipulated variable or classification variable, a lack of random assignment to groups, or a lack of control or comparison to the group. For example, do boys and girls independent variable differ in aggressive behaviors? Now, I cannot randomly change somebody between a girl and a boy. That's why it's quasi-independent, because it can't be manipulated. Now, when you think about quasi-independent, think about something you really can't easily change, like culture, like political affiliation. Are you suddenly going to become a Democrat, Republican, Libertarian, Green Party, or any other one that's out there that you identify with and change it randomly without some sort of process or something? You're probably going to stick with your political party. Are you suddenly going to change your culture and embrace customs that you don't even believe in? Probably not. So culture, political affiliation, gender, all things that are very hard to change. Now, not impossible to change, but difficult to change, i.e. a quasi-experimental variable. For another example, the differences between 20 and 40-year-olds in reaction time. Independent variable is the difference, but I can't make someone 20, I can't make somebody 40. There is no such thing as time travel, at least not yet. Let's hope, right? In reaction time to the dependent variable. So correlational, these are your analyses for prediction. This quantifies the strength and direction of a relationship between two or more variables, X and Y. Variables are measured as they naturally occur. Lack of random assignment lacks control to determine the cause and effect. Example, what is the relationship between SAT scores, X, and the freshman college GPA, Y? Again, correlational. Inversely or non-inverse, like conversely, like they go at the same time or differently in terms of correlational analysis. A correlation is not a causation. One does not cause the other. You just happen to see a variable move with another variable. Now, what is a variable? A variable is anything you identify that you want to measure. If you're operationalizing a variable, that means you're figuring out how you're going to measure it and look at it. There's also something called a confounding variable. That's where you find something that completely changes the results of what it is that you're looking at. Like, for example, the relationship between SAT scores and freshman GPA. A confounding variable might be the amount of sleep that someone gets, for example. So scales of measurement proposed by S.S. Stevens in 1946. He was a Harvard psychologist. He talked about the degree to which measured variables conform to the abstract number system. This includes identity, order, equal distance, and absolute zero, or complete absence of the variable. This determines the type of statistical analysis that are possible. So some scales of measurement. Types indicates what the number represents. Nominal, identity or classification. Think about nominal like an adjective, okay? You can't really change it. It just describes something, male or female. Not impossible, but again, difficult to change. Ordinal, rank or order. Class rankings first through last. Interval, order and equal units, no true zero. Intelligence test scores. Ratio, order, equal units, and absolute zero. Height in inches. So I feel that folks really struggle with understanding variables sometimes. Nominal, identity or classification, what something is. One of my doctoral students did a study on why gang members exit gangs. And it was like all these random things you can't really assign a number to, like they went to jail, they found God, they got married, they had someone really important in their life. Again, nominal variables. Ordinal, there's a rank, class rankings, how you're doing in any class you're taking, say here at Ferrum, in comparison to all your other classmates. That would be your class ranking. Interval, those are your order and equal units, no true zero. So there has to be the same amount of space or distance between each variable, but there's no true zero. I'll give you guys some examples in a moment. And then you also have ratio, order, equal units, and absolute zero. Height in inches is a good way to think about it, but there's some other examples we'll walk through in a moment. So classification of variables. Continuous versus discrete. Continuous, this is measured along a continuum, measured at any place beyond the decimal point. That is the Olympic sprinter's time to the finish race, for example. Discrete, separate and indivisible categories, whole numbers only. Socioeconomic class, pretty straightforward. Quantitative versus qualitative. Quantitative number, qualitative tell me a story. One of the best ways I think to think about it. Quantitative varies by amount, qualitative varies by form or class. Here are some examples. So continuous versus discrete, male or female, discrete, qualitative, and nominal, again, telling a story. Seasons, spring, summer, fall, winter, discrete, qualitative, nominal. Number of dreams recalled, discrete, quantitative, ratio. Number of errors, discrete, quantitative, ratio. Duration of drug abuse, continuous, quantitative, and a ratio. Ranking of favorite foods, discrete, quantitative, ordinal. Ratings of satisfaction, 1 to 7, discrete, quantitative, interval. Body type, slim, average, heavy, discrete, qualitative, nominal. Score from 0 to 100 on an exam, continuous, quantitative, and a ratio. Number of students in your class, discrete, quantitative, and ratio. Temperature, degrees Fahrenheit, continuous, quantitative, and interval. Time in seconds to memorize a list, continuous, quantitative, and ratio. Position in line, discrete, quantitative, ordinal. So again, you want to be thinking about the difference when we look at that. Nominal, identify something. Ordinal, ranking system. Interval and ratio, ranking system, but interval and ratio of equal distance between things. And ratio as an absolute zero, interval does not. So going back to what we were looking at here. Political affiliation, discrete, qualitative, nominal. Again, not easily manipulated. Political affiliation, Democrat, discrete, qualitative, nominal. Type of distraction, discrete, qualitative, nominal. Letter grade, discrete, qualitative, ordinal. Weight in pounds of an infant, continuous, quantitative, and ratio. A college student's SAT score, discrete, quantitative, and interval. Number of lever presses per minute, discrete, quantitative, and a ratio. SPSS, this is statistical software typically used in the behavioral sciences. Yes, we will use it in this course. First exercise that we'll do will be to enter data, and we'll enter data via spreadsheet. You want to open the variable view on your IV, for your IV independent variable, enter abbreviation and name column, adjust in decimal column, create values for the independent variable by clicking on the box with 3 dots, open the data view, your dependent variable, enter the values in column 1 and column 2, and click save file, and now it's there for later analyses. The remainder of the text talks about descriptive statistics, transition to inferential statistics, and so on. So let's talk about some of this a little bit more in detail, everybody. All right, guys, so let's walk through that a little bit. All right, and this is an assignment that you actually have credit for that I'm going to walk you through. So the best way to do this, since this is asynchronous, would be, if you can, and I challenge you to do so, if you are able to maybe read along with me and then pause me and think about it and then unpause me and see if you're right. That'd probably be the best way to go about doing it. Now, in this particular assignment, yes, I'm giving you the answers, but you have to have the understanding of it for it to help. So, for example, the researcher tests whether cocaine use increases the impulsive behavior of mice. Now, we're going to identify these as quasi. We're going to identify the independent variable and the dependent variable, and why those are independent and dependent variables. So like I said, probably best for you to watch what I'm saying or try to do it on your own and then look at the answers as we go along here. So a researcher tests whether cocaine use increases impulsive behavior in a sample of cocaine dependent and cocaine inexperienced mice. So what do you think? Take a moment, think about it. So for number 1, hopefully you paused me or you thought about it for a moment. The cocaine use is our independent variable because we're manipulating it. And then we're presuming to increase impulsive behavior in cocaine inexperienced mice. So your outcome variable is like your dependent variable. So the behavior of the mice being all cracked out from the cocaine, that's why it's a dependent variable. The independent variable is the cocaine use. The next one is a professor tests whether students perform better on multiple choice or fill in the blank test format. So what's our independent or quasi-independent variable? What is our dependent variable? What do you think? Hopefully you paused me. So brief pauses since I'm just recording here. So in this case, the test format or independent variable is presumed to cause differences in the preference or dependent variable. So what's being manipulated is whether it's multiple choice or fill in the blank tests, and the outcome of the students is the dependent variable in terms of how well they might score on the test. All right, number 3, our researcher tests whether smoking by parents influences children's attitude towards smoking behavior. So what do we think? Independent, quasi-independent, dependent? So if you think about this one, parent smoking is a quasi-independent variable. And you might say, well, why? Why is it quasi-independent? Because we're not manipulating it. We're not getting parents to smoke or not smoke. And then the child's attitudes, how they react to the behavior or the outcome variable. Think about dependent, like leaning on the variable. That is your dependent variable. Then you have political affiliation. Right here, right? Because we talk about number 4. A social scientist tests whether attitudes towards morality differ based on political affiliation, if we're talking about Republican or Democrat. Now, we didn't say we're going to manipulate who's Democrat, who's Republican, and like, really, how could you? Like, think through that logically. That really wouldn't make a lot of sense. So the political affiliation is a quasi-independent variable because it's not being manipulated. The attitude towards morality, of course, is your dependent variable. Number 5, a health researcher tests whether the number of calories in a meal changes for liking that meal among a sample of adults. So let's think about that. Okay. Health researcher. Okay. The number of calories in the meal is the independent variable, and the dependent variable is the differences in liking it. It's an independent variable because the number of calories in the meal can be manipulated by the researcher, and then the dependent variable is their feeling about it. Going to stop the share, pause for a second just so we can get a little more light. All right, welcome back, even though it probably doesn't really seem like it with the recording. All right, our next one, let's go back to our screen share in terms of really giving you guys a breakdown here. All right, so our next one is a neuroscientist measures whether levels of dopamine, a chemical messenger in the brain, are altered by the size of a reward. Okay, so we want to think about is what's our independent, what's our dependent variable? Well, in this case, the size of the reward is the independent variable, which is presumed to cause changes in levels of the dopamine in the brain, or dependent variable. So the dependent variable is the levels of the dopamine. That's outcome. The outcome variable is dependent on the size of the reward. So is there more of a stimulus happening between the amount of dopamine released because of the size of the reward, but the size of the reward is what's being manipulated, which makes it the independent variable. All right, number 7, a student tests whether tutoring from a remedial tutor improves performance on a standardized exam. All right, let's think about this. So receiving tutoring from a remedial tutor would be your independent variable because they either receive it or they don't, so it's manipulated. And that is presumed to cause improved performance on standardized exams. So their performance of no tutoring or some tutoring, remedial tutoring, the dependent or outcome variable are the standardized exams. All right. Number 8, a researcher tests whether the type of distraction during recall, auditory or visual, influences the number of words participants are able to recall from a list. What do we think? Well, the different types of distraction, whether it's audio or visual or however they're being distracted, is being manipulated. It's changing. So when you hear manipulated, think changing, and that is presuming to cause a difference on their standardized exams or the dependent variable. Number 9. Number 9. Is that right? Yeah, number 9, a cultural researcher tests whether individuals from different cultures share or differ in the belief that dreams have meaning. So in this case, look at this closely. A cultural researcher tests whether individuals from different cultures share or differ in the beliefs that dreams have meaning. So am I going to change your culture? Are you suddenly going to completely have a completely different set of beliefs because you chose to embrace another culture? Incredibly unlikely. Wherever culture you're from, you're probably going to have that culture your whole life. Culture is fascinating. Everybody believes that culture is correct. For example, obviously pre-pandemic, shaking hands firmly in America, huge cultural thing. If you don't shake hands firmly, it's kind of offensive. It's a bit of a faux pas. In India, you're expected to shake hands limply. In America, shaking hands limply is offensive, yet in India, shaking hands firmly is offensive. So, cultural is something, any sort of culture is not easily manipulated. Therefore, culture quasi independent variable. So, in this case, being from a different culture, because I can't change what culture you're from, quasi independent. And then whether or not dreams have meaning, our belief based on our culture, which is not manipulated, that's our dependent variable. Number 10, a psychologist tests whether employee satisfaction is different among employees working different shifts, day or night shifts. So in this case, working different shifts, because I'm not changing what shifts are being worked, I'm just observing. That is a quasi independent variable, and that is presumed to cause different levels of employee satisfaction, which is the dependent variable. This, which you should be able to see in your classroom, but I will absolutely take a look in a moment, make sure it's there for you, maybe do a screen share and walk you through where that is. The rest of this you can do on your own. Come up with your own list of 5 variables of these: nominal, ordinal, interval, ratio, and why they are. Those label them as continuous or discrete, label them as quantitative or qualitative, and then create an explanation. And it does say PowerPoint, but I would absolutely take a Word document, let's say brief PowerPoint or Word document presentation. So that's the second half you can do on your own. Let's stop the share here and let me make sure you can see this in the classroom. We'll assign that as homework. Should be pretty straightforward to get your feet wet on variables. Okay, so let's do a screen share and show you where that is, everybody. So I'll assign this. Well, I'll give you like a week. You don't have to do it immediately. I'll give you maybe till 11:59 this time next week or over the weekend. So this is going to be right here under chapter 1 in class assignments. And that was the variable types of assignment that I just explained. You only have to do the second half on your own. Hopefully my explanation made that clearer for you guys. The other thing that I'd like you to do is the Dr. Java research study, which is right here. And you can absolutely download it. Just click right there and you should be able to just resubmit that. If you have any problems, anybody with submitting assignments or anything with Brightspace, just let me know and I'll make sure that whatever the issue is gets resolved like immediately. So let's go ahead and stop share. Let's do a new share and I'll walk you through that assignment. And that might just be it for today. Just want to give you a little bit each day to give you a sense of things and explain things. So probably do like an hour or so of lecture, maybe 2 hours. That'll be the max. I'll never be more than 2 hours. I don't want you guys falling asleep or anything. I want you to learn a lot about stats this semester and have a really great course so you all get to the finish line. So this one, let's talk about this. So this is a worksheet. Again, you get credit for this too, just by listening to me explain it and filling it out. And as I give you what these things are, you should absolutely be taking notes and thinking about those and reflecting so that you understand what everything is. So this is, let's make sure I'm sharing the right screen. I want to make sure you guys absolutely see that. Yeah, it looks like that is the case. So this is analysis of a research study. Now this is a fictional study, but I think it's kind of fun. So Dr. Java is interested in marketing his super hyper espresso and believes that his students will make, that believes that his coffee rather, will make students perform better on exams. He goes out and he studies 200 college students who had similar grades. He had his research assistants give half of the students a decaffeinated super hyper espresso and the other half his caffeinated super hyper espresso. Participants were not told which beverage they were given, and the research assistants did not know which beverage was in each cup. He gave the entire group the same final exam and found that the caffeine group performed significantly better on the exam. Given the above example, let's identify the following portions of the research study. Hypothesis. So what do you think the hypothesis is? The hypothesis is an educated guess on something that you think is going to happen. So for the hypothesis, you might say that the students that have the super hyper espresso are going to perform better. It would be however you interpret it. It's probably that or something along those lines for your hypothesis. Those that were given caffeinated espresso, super hyper espresso will perform better on the exams. The independent variable. So we want to think about what was manipulated. The independent variable would be the students receiving either the caffeinated or decaffeinated super hyper espresso. Technically, you have two levels of independent variables here. Again, remember the independent variable is the thing that's manipulated. So caffeinated or non-caffeinated drinks, that is your independent variable. Your control group, well, those are the folks who got the decaffeinated drinks because he felt that the ones that received the caffeine would do better. So that's what your control group would be, the non-caffeinated participants, okay, that received the non-caffeinated espresso. Was this a single blind procedure or a double blind procedure? How do you know? So single blind means the participants don't know what's going on, and double blind means the researchers don't know what's going on. And in this case, it says participants were not told which beverage they were given, and the research assistants did not know what beverage was in either cup. Therefore, it's double blind. I'll give you another example of double blind. My wife and I were part of a vaccine trial, Novavax, which you probably heard of, which is, I believe, approved. It's definitely approved by the CDC. And only the pharmacist knew if we got the placebo or the vaccination. Eventually, everybody got the vaccination, but the information was unknown. Even the doctors that were administering the shots, as well as us, the participants, did not know what was going on in terms of what we were getting, which makes it double blind. Now, your dependent variable, that's your outcome variable or your dependent variable that depends or leans on something. That is the outcome of the performance on the tests. Now, was this study experimental research or correlational research? How do you know? This study was experimental because we had a manipulated variable. It really wasn't correlational. Now, if you wanted to make the case for that, you possibly could, because maybe there was a correlation between the caffeinated students or the non-caffeinated students, and maybe, just maybe, there were some confounding variables we didn't account for, like how much they studied, amount of sleep. But this is more experimental than correlational. Now, if you have a rationale for either of those that you can justify, I'll certainly accept either. Participants, those were the 200 college students. The people in the study are always the participants. The finding, that's like what happened. Now, the finding, that had to do with whether or not the finding had to do with what he found. So if he found that the caffeine group performed significantly better on the exam, that was the finding. And then we have, is a study reliable? Why or why not? Now, reliability and validity are different things. Reliability has to do with the ability to basically get the same results over and over again. Now, there's many different types of reliability. There's many different ways to think about that. Let's just walk through a little bit of reliability, everybody. And we'll go back here. And I believe if we go like this, like this, that, and like that. Okay, let's talk about reliability. You should be able to see that, I believe. All right, so test reliability. We want to get the same results. You want to give measure again to the same people. Calculate the consistency between repeated measures. You might use Pearson's R. Don't worry about Pearson's R yet. This week is just foundational. So for most variables, the test retest is very high. The Fagan test is very high. Usually R is greater than 0.80. However, test retest reliability is not always viable. It can be rapid. There's rapidly changing variables or states, political attitudes, current emotional state. You could do retest reactivity, which might not happen because of boredom. Strive for difference or consistency. Again, can we get the same results over and over again with the same test? So think about Dr. Java. We'll come back to that in a moment. You want to get the same test, retest reliability. Then we have inner item reliability. That's correlation of items within the measure. Move that out of the way. So that's getting in the way here. Split half reliability. 10 items on a self-report measure of depression. Consistency between the first 5 answers and the second 5. Split half reliability. We have corn box alpha, aka internal reliability, average of all possible split half reliabilities, average relationship of items to each other, most commonly used to measure reliability for psychological scales. Here's an example of reliability. Look how close these are. They're not identical, but they're closer for alternate forms on the Fagan test. Don't worry about what the Fagan test is. Just see how the scores are similar. That's your reliability. Inter-observer reliability. That has to do with measures that depend on a rater, aka inter-rater reliability. So like my first job out of college, I worked at a bed and breakfast and we had to rate people on their performance, like the housekeeping staff, the innkeepers, and it was based on my rating and the rating of the owners. And we were looking for consistency of how we would rate them, inter-rater reliability. Have 2 or more people do the same. You want to have 2 or more people do the same ratings. This can be done live or by videotape, transcripts, etc. Calculate the correlation between their ratings. If ratings are in a nominal or ordinal scale, you can't use Pearson's rho. Pearson's R. Note this is an independent. This is independent of test, retest reliability, inter-observer reliability. And then you have, of course, alternate forms reliability. This applies to standardized test surveys where the researcher wants to have more than one version of the instrument. Why more than one version? Avoid cheating. For objective tests to be able to retest the same participants. Avoid boredom in the response set. How to do it? Give the 2 forms of the same group within a short period. Look at consistency between the scores. So you have a reliability problem. You want to assess your reliability. Does it have test retest reliability? Does it have internal reliability, inter-rater reliability? Is there a problem? The researcher has some control over the first 2 sources of random error. So rule of thumb, R should be greater than 0.70. Find the source, inconsistent observers, inconsistent testing conditions, inconsistent items, inconsistencies in the participant's behavior, all reasons it could be unreliable. Some reliability problems to go a little bit further. The observer, training, motivating raters, simplifying the observer's task, counting how many instead of judging the behavior's intensity, using instruments to record behavior. Reliability problems, testing conditions, standardizing administration of your measurement instruments, clarifying instructions and questions. Reliability problem, unruly participants. You want to clarify the difference between the rating scale, like in a Likert item, and a scale when it refers to a combination of items. You want to obtain a multiple measure of a construct or what you're trying to measure and average that together. That could be your scale. Again, that table with some examples, clarify the difference on the rating scale and see how it refers to things such as a combination of items. Obtaining multiple measures of the construct on any one item, some random error, the way it was read, how much attention was paid to it. If the random error is sum and sum, the average should smooth it out, some plus, some minus, the average should smooth it out. However, if you make the scale too long, there could be errors due to boredom, motivation may increase. I used to work in student success, and I had a student once get really bad results on assessing their success, and it was because they had boredom or they rushed through the survey and it wasn't accurate in terms of the reliability of the results. Like, can we trust them? Reliability is about trust and getting the same result over and over again, regardless of the type of reliability that we're talking about. Reliability problems, inconsistent items. To increase reliability, we use scales, multiple items designed to measure the same thing. Items might vary in their quality. Some items might be hard to understand, excessive different concept, etc. Some produce no variability, like the variance, the difference between those things. Then you have item analysis, identifying items that don't correlate well with others, or dropping or improving these items. So reliability summary, it can repeat the results. Think about repeatability, think reliability. Test, retest reliability. Will we get the same results over and over again? Pearson's R is really good for this because if the R is greater than 0, it's good reliability. Don't worry about knowing Pearson's R yet. I want you to understand the concepts today. The concepts are what are important. Then we have internal reliability, or Cronbach's alpha. Give a scale to all participants, then calculate Cronbach's alpha, average of all possible split half reliabilities. If R is greater than 0, again, good reliability. Inner item, different things were being rated. The first 5, the first 10, the last 5, the last 10 on the survey. Inner item reliability. Inter-observer reliability, aka inter-rater reliability. Have 2 different raters rate the same participants at the same time or from a video, then correlate their ratings. If R is greater than 0, again, good reliability. Some fixes, more consistent setting, more consistent participant motivation, better rater training and item analysis. And that should give you a sense of reliability. So we will go back to our Dr. Java study that we were working on together as a group here. So let's go back to that. And that should be right out here. All right, back to Dr. Java. Let's finish walking through that, everybody. All right, so again, if you do these in-class assignments, follow my lead here. You walk through it, you do have the opportunity to earn points on these assignments. Is the study reliable? Why or why not? Remember, we said trust and the consistency of the same results. So I'd probably say it's unreliable because Dr. Java did 1 test. If you look at this example, he didn't do several tests. Now we can make an argument that maybe it is reliable because there was such a large group of people, and we can start thinking about things like inter-rater reliability or item reliability. There's only 1 item, but usually we probably want multiple tests. So for this, I would say, no, it's not, because we only had 1 test. Is the study valid? Why or why not? No, valid is measuring the thing you want to measure. That is what gives you validity or makes something valid. So he literally tested the performance of students on the final exam. And if they were caffeinated, they performed well. And when they were uncaffeinated, they did not, or non-caffeinated. So for this one, I would say it's valid, yet unreliable. Now, the moment Dr. Java has 10 different tests or 5 different tests and gets the same results, then it probably is reliable. Or think about the stimulus checks, guys. Were they very reliable? Did you get them every month? No, they came in once in a while. And that's not a political comment. That's just a sense of the reliability. Was it consistent? Did it happen all the time? I don't think so. There were like 3 or 4 of them or 2 of them or something. We didn't get them a lot. Unreliable. Couldn't count on it. Can you count on it? Reliable. Can you measure the thing correctly? Validity. Now, you can have validity without reliability. This worksheet's a great example. Dr. Java had great validity, did not have reliability because we don't know if we can get the same results over and over again. So that breaks that down. And then the other stuff I'll assign and you'll be on your own for that, but I'll totally walk you guys through it. And that'll probably be just the lecture for today. The goal is just to get your feet wet here. So we have this, which is our hypothetical research study. I want you to come up with an idea of how you might do hypothetical research. Okay, it's whatever topic you want to do. It's absolutely fine. You want to answer these questions. Actually, maybe we'll move this over here and I'll do a new screen share so you guys can see it in a little bit better detail. So let's look at this. All right, so
here we go. Hypothetical research. Maybe let's download this so you guys can see it a little better. Save, and we have it download. I hope. Or we'll just make this bigger so you guys can see it. Okay, so you're going to think about something you want to do or research as a group. Probably in this case, really an individual, so there's just 3 folks in class. State your hypothesis, whatever you want to come up with. Nothing too over the top. Just make it appropriate for class, but almost any topic would be fine. Hypothesis is going to be your educated guess. What is your independent variable? If you want to do a quasi-independent variable, totally fine. What is your dependent variable? What's your outcome variable? Is it possible to experience a placebo effect? Why or why not? What is your experimental group? Tell us why. What is your control group? Tell us why. So people that you do the treatment is your experimental group. Your control group are the people that don't receive the treatment. Is there an experimenter effect or a bias? Let's talk about that. Let's say a child psychologist comes to observe children behavior on the playground. Now you can bet that children are going to be amazing children if they know that's why they're being observed. There would be an experimenter bias in that case. If he said he was observing them for other reasons or nothing related to behavior, they might be a little bit more natural. As we all know, when we were kids, we were probably on our best behavior when we were supervised by other adults. Is it a single blind or double blind study? Why or why not? So again, an idea of research, not necessarily what your thesis is going to be, not anything that's over the top, changing the world, just an idea of what the hypothesis is and how you might go about that if you were to do a study. Again, you're not actually doing the study. I will take a Word document or a PowerPoint document addressing these things. So we're going to do this, which is our types of variable assignment, which I walked you all through. We're going to do this, which is our infographic assignment this week. We'll give you all a week, so don't sweat it. We're going to do our hypothetical research project. I just walked you through. Dr. Java study we did, and icebreaker study should be pretty straightforward. We'll call that it for today to give you just some background. I'll probably lecture again tomorrow, try to do about an hour or two. I'd certainly love to hear from all of you in terms of when you're the most available. I know that there's a lot of athletes, and some of you or all of you might be athletes, and maybe you'll only attend asynchronously. I hope you enjoyed the lecture today. I hope you learned something about descriptive statistics, just the data, inferential meaning, variables, what an independent variable is in terms of if it's manipulated or not, what a quasi-independent variable is, like culture or political affiliation, and of course, how we classify variables and what a hypothesis is, what the findings might be, what participants are. Again, today is just to give you a foundation. So hope you learned something. I'll see you in the next lecture/video, and feel free to reach out to me directly. I think you all have my email. My phone number is 786-879-0179. That is my direct cell phone. I will pick up or I will call you back. You can text me there. I won't get into a conversation with you about statistics over text, but I totally will over the phone, via email, and or via Zoom. My email address is jkmack@ferrum.edu. Please reach out. I have a lot of students pass statistics. I have a lot of students do very well in statistics. The biggest thing is communication. And then, of course, just to give you one more recap, this is where most of your stuff is. You have your syllabus, how to contact me, your books. You have to do Cengage. You get a free trial, so don't be freaked out about spending the $40 if you don't have it today. I can certainly work with you on deadlines if we need to. If you have a big concern, contact me directly. These are our learning objectives. We talked about actually all of this today. And then these are some journal articles which may come into play in terms of research and stuff for class, may not. These are chapter 1 flashcards where you can review the material. These are multimedia resources. These are other people explaining the stuff I've explained. So if this is not clear to you or you want more enrichment, click on these links. They're going to walk you through it. And this, of course, is
again, all the assignments. That's really all you need to be concerned about. Yeah, for this class, for like this week. And let's go ahead and stop the share. All right, everybody, I'll see you in the next class, possibly same time, same place tomorrow. I'll keep posting these and we'll walk through some SPSS stuff tomorrow a little bit. Again, reach out to me directly if you don't have the book or the software yet. Not a big deal. You want to get them soon. And I look forward to seeing you all in class. Hopefully a live class, but if it ends up just being if it ends up you just watching the videos, that's absolutely fine. Take care, and I will see you either asynchronously or synchronously. Have a wonderful day, everybody. Take care.